So what was the last topic? So what were we discussing yesterday? The last topic, Nitish. Example 6 point. We are done with example 6.6, no? Just to recollect the concept. So by the way, those who are online, are you able to hear me?
Yes, sir, you are audible.
So E is equal to half into B R square omega. This is what we got yesterday, right? I told you this expression can be used as a formula to solve other problems as well. So having this in mind, let's try out example 6.7 and then we can go to the next concept. So try this out. So there is a wheel with 10 metallic spokes. So there is a wheel with 10 metallic spokes, each 0.5 meter long. Okay, each is 0.5 meter long, is rotated with a speed of 120 revolutions per minute. So first take down all the data. So length of the spoke has to tell what it tells us about the radius. So radius is 0.5 meter. Is rotated with a speed of 120 revolutions per minute. That speed has to tell us what? What is the speed telling? It is telling us F. Omega would have been radian per minute. F will be revolution or rotation per minute. So frequency is 120 revolutions per minute. There is one common thing which you can always find. You have to convert revolutions per minute to revolutions per second. So 120 revolutions per minute is 2 revolutions per second. Because 1 minute 60 seconds, put it. So it is 2 revolutions per second. Once you know F, can we find omega? Omega is equal to 2 pi into F. So this is equal to 4 pi radian per second. I hope it is clear till this step, right? So it is 4 pi radian per second. HE is given. HE is what? The Earth's magnetic field. The horizontal component of Earth's magnetic field, I will call it as BE also, which is 0.4 cos at a place. What is the induced EMF between the axle and the rim of the wheel? So what is the formula for EMF? Half B R square omega. R square is 1 by 2 the whole square into omega is 4 pi. So this and this will get cancelled. 0.4 divided by 4 into 2 pi. So this gets cancelled twice. So it will be 0.1 pi. Is it right? 0.y into 10 power minus 4, no? Oh, sorry, 0.2. 0.2 into 10 power minus 4 Tesla, because Earth's magnetic field is in terms. Right. So 0.2 into 10 power minus 4 pi Tesla, 1 pi is 3.14. If you see it, it is somewhere around 6.28. So 6.28 into 10 power minus 5 Tesla. Because the decimal is pushed one value to the right. Oh, EMF, no? Yeah, volt. Is it clear? Here, one confusing point that they would have given is, what are the number of spokes that they told? 10. You know, one common mistake that happens is, the final value will generally get multiplied with 10. That is what some people do, but you should not do it. Why? Because if you take this spoke, right, it will be something like this. 3, 4, 5, 6, 7, 8. It keeps. So that is, they have 1, 2, 3, 4, 5. So you have 10 spokes like this, right? So between the center and the point A, what happens? If the value of EMF generated is how much? Is 6.28. 6.28 into 10 power minus 5 Tesla. Now, OA and OB are parallel to each other. Same is the case with OC also. Even if you have 10 more spokes, the EMF that is getting generated across every spoke is going to be the same because they are connected in parallel. Are you able to understand? Point 2 into 3.14 into 10 power minus 4. So this is 0.628 into 10 power minus 4. Then it is 6.28 into 10 power minus 5. Got it? Okay. So is this clear? This is how you solve. So you can use that half B omega, half B omega R square as a formula itself. Clear? Now having this in mind, we need to solve this problem 6.8. So 6.8, if you see again, it is a problem that is based on motional EMF. Okay. So read the question carefully and then start doing it. This is a very, very, very important. I'll zoom in, see. The arm PQ of the rectangular conductor is moved from x is equal to 0 to outwards. Okay, x is equal to 0 in the outward direction. A uniform magnetic field is perpendicular to the plane and extends from x is equal to 0 to x is equal to b and is 0 for x greater than b. Observe. X is equal to 0 to x is equal to b, there is a uniform magnetic field. Beyond b, what is happening? The magnetic field is 0. Is it clear? The uniform magnetic field is perpendicular to the plane and extends from x is equal to 0 to x is equal to b and is 0 for x greater than b. Only the arm PQ possesses substantial resistance R. So PQ is having a resistance of R. Consider the situation when the arm PQ is pulled outward from x is equal to 0 to x is equal to 2b. So the arm PQ is pulled from x is equal to 0 to x is equal to 2b and is moved back to 0. Again, it is moved back from here to 0. So it moves in a cyclic pattern. Are you able to understand till this point? Now, if this is the scenario, then you need to obtain the expressions for flux, induced EMF, force necessary to pull the arm, and power dissipated as joule heat. And we need to sketch the variation of these quantities with distance. So how do these physical quantities, what are the 4 physical quantities? Magnetic flux, induced EMF, force, and power dissipated. Everything should be drawn as a variation of distance. Can you do that? So first draw this diagram. 1 minute. Did you all draw it? Concentrate. So when the when the rod moves from x is equal to 0 to x is equal to b, then is the flux increasing or decreasing? Increasing. So what are all the four physical quantities which we need to find? Flux, EMF, force, and power dissipated. So first let me try to calculate flux. Okay, when I say flux, so flux is equal to how much? dA cos theta, right? B is B only. What is the value of area? From x is equal to 0 to x is equal to b, the area is L into x. L into x. Because L into b is a fixed value. Do you mean to say till it goes till L into b, it goes till b, the flux is a constant value? Try to understand. Like how you told, if I write it as LB, then magnetic field is constant. L is constant and small b is also constant. Is the flux constant when it goes from 0 to b? No, right? Then what should come there? Flux is a function of distance, because we need to sketch the graphs with respect to distance also. Observe that part. So b into L into x, and you can take it as cos 0 degrees. So answer will be b into L into x. From where? From x is equal to 0 to x is equal to b. Then what about b to 2b? This is the conductor that is moving. Remaining thing is a metallic frame that doesn't move. You didn't attend yesterday's class? Missed it? Huh? Okay. So in yesterday's class, I explained it. So the metallic rod is there on which the conductor will move. So the rod, the C-shaped rod is there, no? That is fixed, on which the conductor has the motion, and the conductor will move on a frictionless surface. That surface is frictionless also, because when it has friction, what would have happened? The conductor would have dissipated heat due to friction also, but here the heat is dissipated only due to current. Okay. So B into L into X. When it moves from x is equal to b to x is equal to 2b, then what is the value of flux? This will be b into L into b. Why? It will not be 0. B to 2b magnetic field is 0. It doesn't mean that we mean to say between b 0 to b, when you go when you go from b to 2b, right, between x is equal to b to 2b, what is the amount of flux that is linked with it? That is when it is going from b to 2b, this is the amount of flux, no? So what is the value of that flux? It is the maximum value. Till wherever the magnetic field is existing, the flux will be associated with it. So b into L into b into cos of 0 degrees. So this is going to be BLB. Again, when it is coming from 2b to b, when it is coming from 2b to b, what will happen? Phi will be equal to same BLB. When it is coming from x is equal to b to x is equal to 0, what will happen? It will be BLX. So what is happening here? 1 minute. Sure. Keep copying it first. Let's figure this instead, right? Is it clear or not? Okay. Now, shall we try to draw the graph between the flux and the distance? Yeah. So, how will the graph look like? So, when you go from 0 to B, flux is increasing. And from B to 2B, flux is constant. And from 2B to B, again the flux is constant. And from B to 0, it is decreasing. It is decreasing. Just you're saying that when it goes from 0 to B and from 2B to B, though it is distant, I understand what you're asking. You're not taking the direction into consideration, but how will you draw it graphically? No, but we need to draw it in the same graph. Because below this, I need to bring the EMF also. Okay. So just an additional point here. If I take this as theta, okay, then if you observe, flux is equal to B into L into X, right? Flux is on y-axis. Can I write this as y is equal to mx? So what is the slope of this line? Slope is B into L. Magnetic field multiplied with the length of the rod will give you the slope of this particular graph. Okay. Is it clear? Okay. A correction, that is flux versus distance. That is not B, that is flux. Okay. Between x is equal to 0 to x is equal to B, flux is B into L into X. Then what is the EMF? EMF is minus d phi divided by dt. So is this not equal to minus B into L into dx divided by dt, which will be minus BL? Is it clear? Similarly, when you go from x is equal to B to 2B, EMF is B into L into B, which is a constant, which is also equal to d phi divided by, flux is equal to B into L into B, which implies d phi by dt is a 0. So what does this conclude? EMF will be 0. Similarly, when you move from x is equal to 2B to x is equal to B, what will happen to the flux? Again a 0. So flux is constant, but EMF is 0. Yeah, tell me. When x is equal to 2B to x is equal to 0, flux is what? See, actually, if I have to say flux here, right? Instead of writing it as BLX, can I write it as negative of BLX? Why am I writing minus? Because the flux is decreasing, no? So if that is the case, then what would have been the EMF here? So x is equal to B to 0. X is equal to B to x is equal to 0. What is the flux? It is B into L into x. So EMF will be equal to minus d phi by dt. Again, it will be minus d into L into. Which one? Okay, you took it like that. So here what will happen is the polarity will change. Okay, you want to take this as minus, then this will become plus. Okay. Now the most important part is when you draw the graph between when you draw the graph between EMF and displacement, sorry, distance, x is equal to 0 to x is equal to b, this will be the graph of how much value? Minus BLV. From B to 2B, what will be the value? It will be 0. From 2B to B, it will again be a 0. And from B to 0, it will be, that's it. So graph tells you one thing. EMF will get generated only till there is a change of flux. I'm saying EMF will get generated only till there is a change in flux. So done. After this, what are they asking? You need to find the amount of force that needs to be applied, right? Yeah. So how to find the force? Force is equal to B into I into L. Is it right? So B is B only. What can you write in the place of I? You can write it as EMF divided by the resistance multiplied with the length. So E divided by R into L. Is it clear? So B is B only. What is the EMF that is getting generated between x is equal to 0 to x is equal to B? Due to induced EMF, there will be a current. Current carrying conductor placed in external magnetic field experiences force. And the force is BIL sin theta, no? I into L vector cross B vector. You remember that? Yeah. So B into what is the value of EMF? EMF is minus BLV divided by R into L. So you'll get minus B square L square V divided by R. Is it clear? Similarly, when you go from x is equal to B to x is equal to 2B, what will be the value of force? The induced EMF is how much? 0. So force will also be 0. Similarly, when you go from x is equal to 2B to x is equal to B, what will be the value of force? Again a 0. And when you move from x is equal to B to x is equal to 0, what is going to be the force? B into BLV divided by R into L. It will be B square L square V divided by R. Right? So first copy this. Done. Done. Now see how to draw the graph for it. So when you take from 0 to b, right, it is minus b square L square v divided by r. Similarly, when you take it from b to 2b, how much is it going to be? Force will be 0. When you do it from 2b to b, it will be a 0. From b to 0. It will be b square L square v divided by r. Is that clear? And what is the last value? Power. So what is the formula for power? Power is equal to v square by r. So can I write it as e square by r? What is the value of e? Again, from x is equal to 0 to x is equal to b. The value of e is minus BLV. So power will be equal to minus BLV the whole square divided by r. So this will be b square L square v square divided by r. Okay. Again, from x is equal to b to 2b, what will happen? Power will be 0. X is equal to 2b to b will be 0. X is equal to b to 0 will be. So power will be positive irrespective of whether you are going from 0 to b or b to 0. Am I clear? Is it clear? So this problem, mark it, as I told you, mark it as important. Done. Shall we move on to the next concept? By the way, those who are online, you could understand. Yeah. So we'll go to the next concept called inductance. Okay. So I want everybody to pay attention for this. In the first chapter, in the second chapter, we had a device which is used to store charge. What was the device called as? Capacitor. And what was the property associated with it? Capacitance. So if I ask you capacitance, what will you tell me? It is the property of a capacitor to store charge. Similarly, in the third chapter, we discussed about a device which will offer resistance to the flow of charge. So offer, I can say, hindrance to the charges which are flowing. The device is resistor. Or I can say a conductor itself has a property called as resistance. Means it will not allow the charges to flow that easily. Right? So that property is called as resistance. In a similar way, if you have a device called as inductor, then the property associated with that inductor is what is called as inductance. So if you see all the names, right? Capacitor, the one with ends with OR is a device. Similarly, I have resistor, it's a device. Similarly, inductor is also a device. Then what are the properties? Capacitance, A and C is a property. Resistance, A and C is a property. Similarly, you have inductance also. So what this inductance has to tell us, we'll see slowly. Okay, but before that, let's try to take a particular scenario and understand it. Suppose, let's say I have a wire wound in this form. Okay, it's not a solenoid. Let's say a wire is taken and it is wound in the form of a helical shape. Okay, and you take this winding and connect it across a battery and control it with the help of a key. What will you do? You will control it with the help of a key. Now, if this key is not closed, what will happen? Obviously, there is going to be no current flowing through the device. As soon as this key is closed, what will happen? Current starts flowing. And due to this current, can I say there will be a magnetic field associated with this region? Right? So there is a magnetic field associated with the region. So from t is equal to 0 till it took a steady state value. So from t is equal to 0 till the current takes a steady state value, can I say there is an increase in the value of current that is happening? It might take microseconds or milliseconds or whatever it is, but during that time, there is a increase in the value of current taking place. And due to the increase in current, there is an increase in the magnetic field taking place. When there is an increase in magnetic field, there is a change in magnetic flux also taking place. So what are the properties? I is increasing and B is increasing. When B is increasing, phi is increasing. So when I say whether flux is increasing or decreasing, can I say EMF is induced? So here the point is, you already have a potential source. Apart from having a potential source, due to the magnetic flux that is changing within the coil, there is another EMF that is getting induced, right? And that will get induced at the ends of this conductor, which is positive, which is negative. We will discuss about it later. Okay, but am I clear till this concept, right? So what is happening within this device? These are the three changes: I increasing, B increasing, flux increasing, as a result of which EMF is induced. So if EMF is induced, right? Generally till now, if you see, we had a separate coil and we had a magnetic source. It is due to the change in the flux created by the magnetic source, there is an EMF induced in it. But here what is happening? You already have a current carrying conductor which is connected to a battery, and the EMF within itself is induced due to the change of its own flux. Is that not what is happening there? Right. So the change in flux is taking place due to its own current, and the EMF is generated due to the change in its own flux. So that is why this kind of an inductance is also called as self-inductance. So what is it called as? It's called as self-inductance. Okay, let's try to understand what the self-inductance have to tell us. Can I say that the amount of flux associated, that the amount of magnetic flux associated with the coil is directly proportional to the amount of current flowing through it? Can I say that? So N times phi B is directly proportional to I. Now, if I remove the proportionality symbol, what am I going to get? S. So N times phi B will be equal to L into I. Right? Where this L is what is called as inductance. Okay. Which implies L will be equal to N into phi B divided by I. So this is one of the mathematical expressions of inductance. Now, what is going to be the SI unit for it? Now, what is going to be the SI unit for it? So flux is measured in Weber. Flux is measured in Weber, and I is measured in ampere. So Weber per ampere is also called as HENRY, which is Henry. So the unit of the SI unit of inductance is Henry. Enough? So I hope it is clear till this step, right? Okay. Now listen. N times phi B, you're writing it as L into I. Now, if I differentiate on both sides, what am I doing? If I differentiate on both the sides, I'll get d by dt of n into phi B is equal to L into I. Sorry, d by dt of L into I. Right? So what can come out of the derivative? N into d by dt of phi B will be equal to L into di divided by dt. Is it clear? So n into d phi B divided by dt, what is it? N times rate of change of flux is what? EMF. Actually speaking, it is negative of EMF, because E is equal to minus d phi by dt. So minus E is equal to L into di divided by dt. Is it right? So if I take magnitude on both the sides, so listen. To be more specific, from this I can conclude that EMF is equal to minus L into di divided by, shouldn't that L? N times ER. The rate of change of total magnetic flux is what is EMF. Yeah. So E is equal to minus L into di divided by dt. So if I take magnitude on both the sides, magnitude of EMF is equal to L into di divided by dt. Right. I suggest you all to write it along with me. Sure. N times d phi by dt தான் வந்து EMF. Done. So magnitude of EMF is equal to L into di divided by dt. Then how can I write L as E divided by di by dt? Can I write it like this? So I already gave you one more mathematical expression. What is it? L is equal to n phi divided by I. This is one of the expressions for L. That is, if at all they give you in a problem, they give you the total magnetic flux and current. If you divide the magnetic flux with current, that should give you inductance. That is one way of finding. Suppose in the problem they give you EMF and di by dt. What is di by dt? It is a rate of change of current. Then that is also equal to inductance. Okay. Now this is where I have something important to tell you. Listen. R is equal to V divided by I. Suppose I replace V with E. Can I write it like this? R is equal to EMF divided by current. For example, if I write it like this, then what can I say is the relation between resistance and current? Inversely proportional. Based on that, what is the property you can say about a resistor? Resistor will oppose the flow of current, right? Because they both are inversely proportional. I repeat it. Resistor's job is to oppose the flow of electric current. If that is the case, then what will be the job of an inductor? Here, if you say R is inversely proportional to I, here what is inductor proportional to? So the work of, if the work of resistor is to oppose the flow of current, work of an inductor is also to oppose only, but it will not oppose the flow of current, it will oppose the rate of change of current. In the sense, inductor will not allow the current to change with respect to time. You cannot take that because the first, why did I compare only these two? Because what is common in the numerator? EMF. There it is flux, no. So I cannot compare with that. Okay. So I repeat it. Inductor's job is to resist the change of current with respect to time. Means it will not try to allow alternating current to pass through it easily. So about this point, you will learn more in the next chapter, but here I wanted to explain this. So inductor means most of them think that it will induce something. It will not induce or do anything. It will not allow the change of current to take place within it. That's it. Okay, that is why it will generate an EMF to protect, and that EMF is called as back EMF. I'll come to that slowly. So have this word back EMF in your mind. We'll go step by step. Is this point clear? So write it down. Inductor opposes what? Rate of change. Rate of change of current. Inductor opposes the rate of change of current. This is clear, right? Now, having said this, our job is to find what is the self-inductance of a solenoid. I'll say a long solenoid. Of length L. So let's say there is a solenoid of length L that is available in our hand, and you want to find what is the value of self-inductance of this particular device. Okay, let's say the solenoid is of length L. The number of turns be capital N, and small n be the number of turns per unit length. So what are the two formulae I gave you for inductance? Check here. L is equal to N phi divided by I, or L is equal to EMF divided by di by dt. Out of these two, which one do you think is easy to apply for this? Di by dt, I need to know what is the change. It is N phi by I because you know it is a solenoid. For a solenoid, you already know the formula for magnetic field. So what I'll do is I'll find L, I'll write L is equal to N into phi divided by I. So N is the number of turns. What is the value of phi, guys? It is B into A into cos 0 degrees. Why did I write B cos 0? Because aerial vector is this side and magnetic field is also in the same direction. Those who are online are able to understand?
Yes, sir.
Right. Now see, this will be equal to N into, what is the value of B, guys? What is the value of magnetic field generated due to a solenoid? Mu naught small n into I into, what is the area of each turn of the solenoid? It takes the shape of a circle. So it is pi r square into, where r is the radius. Okay, cos 0 is 1 divided by I. Is there any doubt in this step? I'll give you a minute time, observe it. Any doubt, let me know. Is it clear? Compared to thicknesses. How will it work? Because area is taken, flux is taken. You all as ignore panana, then there is no concept of inductance. Is that step clear? So in the place of capital N, I wrote capital N. In the place of B, I wrote it as mu naught into small n into I. Into in the place of area, I wrote it as pi r square divided by I. So what will get cancelled? I and I are gone. So you'll be left out with mu naught into, what is small n? Capital N divided by L. So capital N divided by L, and you already have an N here. So what will happen? It will become n square divided by L into pi r square. So what will be the answer? Mu naught n square pi r square divided by L is one of the formulae. This value you are expected to remember. If not, at least you should be in a position to derive it. It's only 2 steps, right? Or L, can I write it as mu naught into, in the place of capital N, can I write it as small n into L? So n square L square into pi r square divided by L. One n will get cancelled. You will have mu naught n square pi r square. So these are the 2 formulae that are related to the self-inductance of a solenoid. LSN, sorry. Is it clear? So this is what happens. Mu naught n square L into pi r square divided by, pi r square. Sometimes what happens is, if the medium between the solenoid is replaced with a material of permeability mu. I repeat, if the medium between the solenoid is replaced with the material of permeability mu, okay, then we know this expression, right? Mu r is equal to mu divided by mu naught, which implies mu will be equal to how much? Mu naught into mu r, right? So L, what are the 2 formulae that you wrote? You wrote mu naught n square into pi r square divided by L, no? So what are you supposed to do to this mu naught? Mu naught, you should replace it with mu. Why? Because mu naught is the permeability of free space. If that medium is replaced with the material of permeability mu, then mu naught will become mu. So L will be equal to mu into n square into pi r square divided by L. But what is mu? Mu naught mu r into n square into pi r square divided by L. Or L is equal to what? Mu n square L into pi r square. But what is mu? It is mu naught into mu r into n square into L pi r square. These are the 2 formulas. These 2 formulae are important. Remember it. In the next chapter, we'll be discussing under in an example problem. We use these 2 formulas. But otherwise, is the concept clear? So what did we learn? We try to understand what self-inductance means. So once you know what is self-inductance, then we try to understand how to calculate the self-inductance for a solenoid. So the next type of inductance that we have is, any idea? The induced standard. The next one is called as mutual inductance. You would have learned about this in your 10th grade. I don't think you would remember, but yeah, you had it. It's called as mutual induction. Okay. So next topic we'll see is mutual inductance. Then we have AC generator, and the last topic is eddy currents. With that, we are done with this chapter. This is actually a small chapter. Next chapter is again big. So is it clear? So that's it from my side for today. Those who are online, Guys, could you understand? Any doubts?
No doubt, sir.
Sir, could you scroll up?
You want me to scroll up?
Yes.
Is this fine?
Yes, sir.
Front look. Yeah, you done copying?
Yes, sir.
Okay. We'll wind up now.